In this video, we're going to look at two examples of multiplying rational expressions and making sure our answer is completely simplified. I see from my examples that I have polynomials in the numerator and denominator, which means I'm going to factor. So instead of reading all these polynomials, we're just going to go right to the process. I want to make sure before I do any cancellations that my numerators and denominators are completely factored. So I have w squared minus 11w plus 24. I want two numbers that multiply to give me a positive 24, add to give me negative 11. Well, a negative sum and a positive product means a negative and a negative. So to give me negative 11 would be negative 8 and negative 3. That multiplies to give me positive 24 as well. On the bottom, the same idea. It's a trinomial. They multiply to give you 80, and they add to give you negative 18. And so I need to figure out what multiplies to give me 80 and adds to give me negative 18. That would be negative 10 and negative 8. Move up to this numerator. They multiply to give you 50, add to give you negative 15. So again, I have a positive product and a negative sum, so a minus and a minus. Multiply to give me 50, add to give me negative 15, or negative 10 and negative 5. And the last one, w squared minus 9w plus 20. They multiply to give you 20 and add to give you negative 9 or negative 5 and negative 4. So factoring is the key when multiplying rational expressions involving polynomials in the numerator and denominator. Make sure you have everything factored first before you do any canceling. Now, it doesn't matter if you have a factor on the top left and on the bottom right. Anything you see on the top and bottom that they have in common, you cross out, you cancel out, because you're really doing division and getting the number 1. So if I take a look, I see a w minus 8 on top here and a w minus 8 on bottom. So I can cancel those out. I continue on, I have a w minus 10 up here on the top and a w minus 10 down here on the bottom, and that's okay. I have a w minus 5 on top, a w minus 5 on bottom. And so all I'm left with on top is a w minus 3. All I'm left with on the bottom is a w minus 4. And remember, you cannot cross out the w's. They are attached to a minus sign. This is an actual term. W minus 3, 3 less than W. W minus 4, 4 less than W. You cannot cross out any variables that are attached to a plus or a minus sign. And so your final answer is W minus 3 over W minus 4. Let's apply the same concept for this example over here. Right off the bat, I see x squared minus 16. I'm going to factor that down using difference of squares. Square root of x squared is x. Square root of 16 is 4. So I have one factor that's x plus 4 and one that's x minus 4. I look at the bottom, I have 12y plus 36. What I have here is a GCF of 12. I factor it out. I get y plus 3. I'm multiplying by, I'm going to have to factor the numerator. Y squared minus 3y minus 18. Numbers that multiply to give you negative 18 and add to give you negative 3 are negative 6 and positive 3. Same thing on the bottom, x squared minus 12x plus 32. Numbers that multiply to give you 32 and add to give you negative 12 are negative 8 and negative 4. Now that all my numerators and denominators are completely factored, I can cross out anything in common on the top and the bottom. I have an x minus 4 here, an x minus 4 here. I have a y plus 3 here, and a y plus 3 up here. If I take a look, that looks like all of the common factors. So what remains? This x plus 4, this y minus 6 in the top. On the bottom, I have a 12 and an x minus 8. And as that is the completely simplified rational expression after multiplying those two rational expressions together. So the key is make sure all the numerators and denominators are factored completely, and then cross out any common factors you have at the top and the bottom to simplify.